Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a triangular prism with base side 50 millimeter and axis height is provided to us as 75 millimeter. Now this triangular prism, it stands on its base on the horizontal plane with a rectangular face perpendicular to the vertical plane. So now let us first of all evaluate the orientation of this triangular prism with respect to the two reference planes over there. Now if the triangular prism is resting onto the horizontal plane into this orientation, then we observe that none of the rectangular faces of this triangular prism will be perpendicular to the vertical plane. So this is the incorrect orientation of the triangular prism with respect to the two reference planes over there. Similarly, if we choose this orientation of the triangular prism as it rests onto the horizontal plane on one of its triangular faces, then we observe that one rectangular face, that is this one. So this rectangular face will happen to be perpendicular to the vertical plane. So here we can check. This is the rectangular face 1, 2BA, which will be perpendicular to the vertical plane. So this orientation of the triangular prism, as it is resting onto its base on the horizontal plane, it satisfies this condition that one of the face of this particular triangular prism happens to be perpendicular to the vertical plane. So we have to choose this orientation of the triangular prism onto the horizontal plane. Now we have been provided with the information that this triangular prism has been cut by an auxiliary inclined plane in such a way that the true shape of the section, it is a trapezium of parallel sides 50 millimeter and 24 millimeter. So now rather than providing us with the angle of inclination of the auxiliary inclined plane with respect to the horizontal plane, now we have been provided with the true shape of this cut section of the triangular prism when the triangular prism has been intersected by an auxiliary inclined plane perpendicular to the vertical plane and inclined to the horizontal plane. Here we are required to locate the orientation of the cutting plane as it is going to intersect with the triangular prism. Now we have been provided with the information that the true shape of the cut section happens to be a trapezium. So trapezium means that there will be two opposite edges which will be parallel to each other, and we are going to get 4 points of intersection because trapezium is a shape in which we are going to get 4 corner points over here. And now we know that the true shape of the cut section happens to be a trapezium having parallel sides 50 millimeter and 24 millimeter. Now if the cutting plane is going to cut triangular prism in such a way that the true shape should be trapezium, then what should happen? The cutting plane should be passing through the top face of the triangular prism as well as the bottom face or the base of the triangular prism. That is only when we are going to get 2 points of intersection at the top face and 2 points of intersection, they will be available corresponding to the base of this triangular prism. Now we need to locate the position of different points of intersection so that we should be able to obtain the true shape of the cut section as the trapezium over here, which is going to have the parallel sides 50 millimeter and 24 millimeter respectively. Now here, as we have discussed, in order to obtain the trapezium, so we should obtain first of all 4 points of intersection. So 2 points of intersection, they should be available onto the top face. 2 points of intersection, they should be available onto the bottom face or the base of this triangular prism. Now we know the dimensions of these parallel sides over here. So one parallel side of the trapezium, it is measuring 50 millimeter, and other parallel side of the trapezium measures 24 millimeter. Now, in order to obtain the trapezium true shape cut section dimensions over here, now we must ensure that first 2 points of intersection of the cutting plane will be obtained onto these two adjacent edges of the base of this triangular prism in such a way that the distance between these 2 points of intersection, it should be equal to 50 millimeter over here. So that is why we assume that the point of intersection of the auxiliary inclined plane with the base of the triangular prism will happen to lie onto the extreme ends of the edges 3,1 and 3,2 over here. So first 2 points of intersection we have obtained over here. That is the distance between these 2 points of intersection obtained on the base will be equal to 50 millimeter. Now, the next 2 points, they will be available on the top face of this triangular prism. Now, how do we locate these 2 points? Now, once again, we have located this center line of the top face of the triangular prism over here. Now, we know that the second parallel edge of the trapezium, it happens to measure 24 millimeter. Now, corresponding to the center line, we are going to mark a distance of 12 millimeter on this side and 12 millimeter on this side, so that once we obtain 2 points of intersection onto the top face of this triangular prism, the distance between these 2 points, it will be equal to 24 millimeter, and this distance of 24 millimeter will be spread equally about the center line over here. That is 12 millimeter on this side and 12 millimeter on this side. So once again we can check these 2 points of intersection on the top face of this triangular prism. They happen to lie onto the adjacent edges of the top face of this triangular prism. So this way, on the top face, 24 millimeter distance will be there between the 2 points of intersection, which have been obtained by virtue of sectioning of the triangular prism by this auxiliary inclined plane. Similarly, onto the bottom face, since the distance between 2 points happen to be 50 millimeter, so this is the maximum dimension 50 millimeter which will be available over here alongside these 2 extreme points of the base over here. So the first 2 points of intersections will be lying over here. Now we could have taken it other way around also. We could have taken the extreme points of 50 millimeter, they will be lying over here. Then the bottom points of intersection having distance between these 2 points 24 millimeter, we could have obtained over here also. So either way around, we have to make sure that 2 points of intersection, they will be available on the bottom face, while the 2 points of intersection of the auxiliary inclined plane with the triangular prism will be available onto the top face over here. Only then the 4 points corresponding to the cut section shape of the trapezium will be obtained over here. So with this information, we are required to evaluate the section front view, section top view, projections, as well as the true shape of the cut section of this triangular prism. So to begin with, first of all, we are going to draw the top view projections of this triangular prism, as this prism is resting on one of its triangular faces onto the horizontal plane. And we know that this edge, that is 1, 2 edge, happens to be perpendicular to the vertical plane, or we can say the rectangular face 1, 2, BA. So this rectangular face of the triangular prism happens to be perpendicular to the vertical plane. So once the observer is going to look at this triangular prism from the top, so we are going to obtain the triangular projections of this prism onto the horizontal plane obtained below the XY reference line. So we know the edge length. So edge length happens to be 50 millimeter. So using this edge length, we have drawn the equilateral triangle below the XY reference line. So we know that the bottom face or the base is represented by the points 1, 2 and 3. So these 3 points we are going to mark on the inner side of this triangular projections, while the top face of this triangular prism is represented by ABC. So the top view has been marked as small a, small b and small c, and these 3 points they have been marked outside these triangular projections over here. Now we have to locate the axis of this prism. So in order to locate the axis point corresponding to this triangular prism, we need to draw perpendicular bisectors from 3 corners of the prism onto the opposite edge over here. So please check, from point 3 we have drawn perpendicular bisector of the edge 1, 2. From point 2 we have drawn perpendicular bisector of the edge 1, 3. And from point 1 we have drawn perpendicular bisector of the edge 2, 3 over here. So wherever these 3 perpendicular bisectors they are going to intersect with each other, we are going to obtain the axis points O and O1 over here. So O point, it is the axis point corresponding to the top face of this triangular prism, whereas O1 point happens to be the axis point corresponding to the base of this triangular prism. Now having drawn the top view projections and identified the axis point over here, now we mark the axis into the front view projections over here. Now we know that the height of the axis of the triangular prism happens to be 75 millimeter. So we have marked this axis height or height of the triangular prism as 75 millimeter over here. So with this, now we can complete the front view projections of this prism over here. So we can check, we have got points B and A of the top face, they will be projected as B dash and A dash, and point C of the top face has been projected as point C dash over here. Now corresponding to the base, points 2 and 1 they have been overlapping with each other and they will be projected as points 2 dash and 1 dash onto the XY reference line. Similarly, point 3 of the base, it has been projected as point 3 dash onto the XY reference line. Now we can check points 1 dash, 2 dash, 3 dash, they are available on the XY reference line because they are representing the 3 corners of the base over here. Similarly, points B dash, A dash and C dash, they have been marked corresponding to the top face of this triangular prism. So these points have been marked at a height of 75 millimeter above the XY reference line. So one thing we must understand, the vertical edge A1, it is lying on the rear side of the solid, so it should have been drawn as dotted line projections or the hidden line projections in the front view, that is B dash 1 dash should have been drawn as a dotted line. But since edge 1A, it is being superimposed by the vertical edge B2 over here, so the object line projections corresponding to B dash 2 dash, so they have superimposed or overlapped the dotted line projections corresponding to the vertical edge A dash 1 dash over here. So that is why we are not able to see hidden line projections corresponding to the vertical edge A dash 1 dash over here. Now let us mark the axis points O dash and O1 dash into the front view projections over here. So point O dash, we have already discussed, this is corresponding to the point O, which is lying onto the top face of this triangular prism. Similarly, O1 dash point, it lies onto the base of this triangular prism over here. Now let us mark the distances of the parallel sides of the trapezium. So as we have already discussed, now we must remember one thing, that an auxiliary inclined plane has cut this triangular prism in such a way that the true shape of the cut section will be a trapezium. So trapezium means we need to obtain 4 points of intersection onto this triangular prism to be able to obtain true shape of trapezium over here. So 2 points of intersection will be available onto the top face, two points of intersection, they will be available onto the bottom face or the base of this triangular prism over here. So this way, once we know that we need to obtain 4 points of intersection, now the location of those 4 points of intersection needs to be located onto the front view and the top view projections over here. Now we know that the parallel sides of the trapezium, they are going to measure 50 millimeter and 24 millimeter. So now we have discussed that the shorter edge of the trapezium, it is going to lie on the top face of this triangular prism, while the longer edge of this trapezium will be lying onto the base of this triangular prism. Now we can check. This is the center of symmetry of this triangular prism top view over here. So corresponding to the center of symmetry line, now we have to mark the location of points of intersection that these two parallel sides of the trapezium, they should be located in such a way that the distance between 2 points of intersection, it should be 24 millimeter corresponding to the top face. Distance between 2 points of intersection, it should be equal to 50 millimeter and it should be located onto the base or onto the bottom face of this triangular prism over here. Now, corresponding to the top face, which is A, B and C over here. So we know that this is center of symmetry line. So corresponding to the center of symmetry line, what we have to do? We have to identify 2 points of intersection alongside these two adjacent edges of the top face over here. That is CA and CB over here, such that the distance between these 2 points should be equal to 24 millimeter over here. So this distance should be equal to 24. That is from this center of symmetry line, that is 12 millimeter above the center of symmetry line and 12 millimeter below the center of symmetry line. So this way, once we measure that this distance between these 2 points of intersection, it will be equal to 24 millimeter. So these 2 points of intersection we have marked onto the top view projections corresponding to the top face intersection with the cutting plane, that is CA and CB has been intersected by the cutting plane at these 2 points. So now we have drawn a vertical projector from the top view projections into the front view projection over here, so that this point of intersection, this has been evaluated onto the top face projections A dash, B dash and C dash over here. So these 2 points of intersections, they have been labeled as P and Q. That is, point P lies onto the edge CB over here of the top face. Point Q lies onto the edge CA over here. So these are 2 adjacent edges. And the linear distance between the points P and Q in the top view projection should be equal to 24 millimeter, which happens to be one of the edges of the trapezium over here. Now, from P and Q, once we draw the vertical projector into the top view projections, so the points P dash and Q dash, they have been located onto the top face of this triangular prism. That is, through this point, the cutting plane should be passing over here. So 1 point of orientation of the auxiliary inclined plane has been located into the front view projections over here. Now let us locate the next 2 points of intersection. So the next 2 points of intersection, they will be points R and S over here. This is point R, this is point S. So why we have located these 2 points R and S? Because we know that the other parallel side of this trapezium happens to be 50 millimeter. So the distance between the 2 points of intersection should be 50. Now we know that the maximum edge length of this triangular base, it happens to be 50 millimeter. So in order to obtain one of the parallel sides as 50 millimeter, so what do we mean? The cutting plane should be intersecting the 2 adjacent edges of the base, that is 3, 2 and 3, 1 over here. So these are two adjacent edges of the base which have to be intersected by the cutting plane. Now the cutting plane has to intersect with these two adjacent edges 3, 1 and 3, 2 in such a way that the distance between the 2 points of intersections, it will be equal to the maximum edge length, that is 50 millimeter over here. So we assume that the cutting plane is going to cut 3, 1 and 3, 2 at the extreme points over here. That is, point R is going to overlap with point 1. Point S, it is going to overlap with point 2. Only then the distance between 2 points of intersection of the auxiliary inclined plane with the base of the triangular prism will become 50 millimeter. Had it been 40 millimeter, so we would have obtained this distance somewhere here over here. Had it been 30 millimeter, we would have obtained this distance over here. Since it is 50 millimeter, which is equal to the maximum edge length of the base of the triangular prism, so point R, it coincides with point 1 and point S, it coincides with point 2. Now let us locate these 2 points into the front view projections of this triangular prism. Now as we take vertical projector from the points R and S, so the intersection of this projector line with the points 2 dash and 1 dash in the front view will provide us with the location of the points R dash and S dash onto the base of this triangular prism over here. So the second point which is going to define the orientation of the cutting plane or the auxiliary inclined plane has been located into the front view projections over here. So now we can join R dash S dash with P dash Q dash over here. So this way we have been able to locate the orientation of this cutting plane or the auxiliary inclined plane with respect to the horizontal plane. So here this is an auxiliary inclined plane which happens to be inclined with respect to horizontal plane at this particular inclination angle, and this cutting plane happens to be perpendicular to the vertical plane, and that is why we have been able to obtain the edge view projections corresponding to this cutting plane into the front view projections over here. Now we assume that this portion of the triangular prism has been removed and this portion has been discarded, and we are left with the remainder portion of the solid which has been darkened over here. So this portion of the solid will be the remainder portion of the solid which is left behind. So this way the front view projections of the remaining solid we have obtained, and this is the remainder portion of the solid, that is distance between points A, B and C. If we join all 3 points, so this will provide us with the remaining solid which is available with us from the top view projection, and the top view projections corresponding to the section solid will be, once we have drawn the projector from P dash Q dash, so this portion of the solid, it represents the apparent shape projections corresponding to the cut section. Since this auxiliary plane happens to be inclined with respect to the horizontal plane, so the projections which are obtained in the top view corresponding to this cut section, that is P dash, Q dash, R dash and S dash over here. So these projections P, Q, R and S, so these projections, they represent apparent shape projections obtained in the sectional top view over here. So now we have been able to obtain the front view projections of the section solid, the top view projections of the section solid, and we have also been able to locate the orientation of the auxiliary inclined plane with respect to horizontal plane and the vertical plane. Now we need to obtain the true shape projections of this particular cut section, that is P dash, Q dash, R dash and S dash over here. So in order to obtain true shape projections of this cut section, as the observer is going to look at the solid from this direction, we need to draw an auxiliary inclined plane x1, y1 parallel to this cutting plane over here. So parallel to this cutting plane, we have drawn an auxiliary inclined plane x1, y1 over here, such that the projections of these 4 points P dash, Q dash, R dash and S dash obtained onto the auxiliary inclined plane, that is the projections of auxiliary plan projection. So the auxiliary plan projections will be providing us with the true shape projections of the cut section over here. So now we have drawn projector lines onto the x1, y1 reference line such that these two projector lines, they should be drawn perpendicular to the AIP x1, y1 over here. Now the auxiliary plan projections will be obtained onto the AIP x1, y1 to obtain the true shape projections of this cut solid over here. Now we know the distance of the point P from the reference plane xy over here. So once we measure the distance of point P from the xy reference plane, now onto the projector line drawn through the point P dash ahead of the plane. Now we are going to mark this distance from x1, y1. So from x1, y1, the same distance of point P will be marked over here. So we will be obtaining this point, which will be the auxiliary plan projection corresponding to this point P, whose distance we have already measured and transferred over here, right? So whose distance we have already measured from the xy reference line, and we have transferred this distance ahead of the auxiliary inclined plane x1, y1 over here. Now the next point of intersection we have got is point Q. So now we are going to measure the distance of the point Q from the xy reference line. Now onto the projector line emerging through the point Q dash ahead of the plane, we have marked the same distance over here. So we obtain the point Q1, which is the plan projection corresponding to the point Q onto the auxiliary inclined plane x1, y1. Now the next point available with us is point R. So we have measured the distance between point R and the xy reference plane. Now onto the projector line emerging from the point R dash ahead of the plane. So the same distance of point R from the xy reference plane has been transferred into the auxiliary plan projection view over here. So we obtain the point R1 at the same distance, that is distance between point R and the xy reference line over here. Last point available over here is point S. So again we measure the distance between point S and the xy reference line. So once we measure this distance, now onto the projector line emerging through point S dash ahead of the plane, that is from the x1, y1 reference plane. So the same distance of the point S from the xy reference line which we had measured earlier, so same distance we have to transfer it out over here. So this way we have been able to obtain all the 4 points of intersection in the plan projection view. And now once we join all of these 4 points, we observe that the true shape of the cut section of which has been obtained over here, it happens to be a trapezium having one edge. It is equal to 24 millimeter. We can check distance between P and Q happens to be 24 millimeter. So distance between P1 and Q1, it is also equal to 24 millimeter. Similarly, the distance between points R and S, it happens to be 50 millimeter. So same way, distance between R1 and S1, it will also be equal to 50 millimeter. So we are having a trapezium true shape corresponding to this cut section of the triangular prism, such that 2 parallel edges of this trapezium we have been able to obtain, having edge lengths 24 millimeter and 50 millimeter respectively. So P1, Q1 happens to be 24 millimeter and R1, S1 happens to be 50 millimeter. So this way we have been able to obtain the sectional front view of the cut solid, sectional top view of the cut solid, and we have also been able to obtain the true shape of the cut section. And into this case, since the true shape dimensions they were provided to us, so we have been also able to appropriately locate the location of the auxiliary inclined plane into the front view projections over here. So this is all for today. So I hope that through this discussion you would have understood about the procedure. How do we evaluate the sectional front view, the sectional top view, and the true shape projections of the cut section of the solid? We are going to continue with further discussion regarding few more illustrative cases of sections of the solids in the coming lectures. So thank you very much. Thanks a lot.